NextPCB is a leading provider of reliable PCB fabrication and assembly services for engineers, startups, and businesses worldwide. Specializing in quick-turn prototypes to mass production, we offer multi-layer, HDI, flex, rigid flex, and metal core PCBs with strict quality control and superior customer care. Our advanced facilities ensure reliable performance for applications across consumer electronics, automotive, medical industries, and more. Embracing Industry 4.0 digitization, we streamline the entire electronics manufacturing process to give you competitive pricing and fast lead times, without compromising on quality. And our user-friendly online platform provides instant quotes, order tracking, and full transparency. In addition to PCB fabrication, NextPCB offers comprehensive PCB assembly services including global parts procurement, testing, certification, and box builds. Our 36 automated assembly lines include advanced inspection tools such as SPI, ALI, and X-ray, reflecting our commitment to quality and reliability. Choose NextPCB for exceptional electronics manufacturing solutions you can depend on.
You can see the NextPCB link by going to the More under this video. Click that, scroll down, and right here is check out our sponsor, NextPCB. Thank you. If you haven't downloaded QUCS Simulator yet, go to QUCS Simulator Tech Talk 102 to learn how to download or to find and download the QUCS from the internet. Welcome to Tech Talk 130. Here we're going to be using the QCS simulator to build and simulate the power supply we just constructed. As you can see here, we're going to have an AC step-down transformer from 120 volts to 24 volts AC. To make our pulsating DC, we're going to have our 1N4001 CR1 and CR2, making a half-wave rectifier. CR3 and CR4 are also 1N4001s. We have our 2,000 microfarad capacitors, 2,200, microfarad capacitors for our filtering caps to turn that pulsating DC into a smooth DC to feed into our IC. This is IC1, which is the LM317T. R2 is our 180 ohm resistor. R3 is our 2.5 k ohm rheostat. C3 is our 1 microfarad titanium capacitor. CR3 protection diode. Here is IC2. Down here is our LM337T, our negative supply. R4, which is our 2.5 k ohm adjustable resistor, which we got it in a rheostat configuration. R5 is a 180 ohm quarter watt resistor to help for the biasing. C4 is like C3. It's a 1 microfarad titanium capacitor. And then CR4 is a 1N4001 diode used for protection. We'll ground this, you have to have ground this, but on the simulation, I also have to put a ground here, which in real life you don't do. Okay, let's get to it. Okay, I opened up QCS. I created a new project. I selected the project tab, new project. I named it JAMECO adjustable power supply. Then I went to add a file to the project. I selected that. It is pointing to my hidden.QCS file where I installed or copied over the example from the QCS homepage. Double clicked, opened up the schematic that we have right here. Then I save all, just so I don't lose my work. And this is what we're going to begin with. Now this is reading from right to left. Our schematic reads left to right. We just put the mirror image into this. I'm going to move my graph down to here, my transient variables down to here, and my equations down to here. So I can get this out of the way. I'm going to bring this over to here. Whoops. See if I can use the keys, arrow keys. Good, very good. Bring it over here and bring it down. Gonna bring that over to here. I use the arrow keys as well. Okay, that's a good start. So let's just make sure this is working. We'll hit the simulation button. Hit processed. No errors found. And this is what we get out. All right. Now that we know this is working, we know our transformer is set to a 1-to-1 because our pulsating DC is 120 volts out as well as we have 120 volts in. So we get our calculator. Bring that over here. Clear this. We look at our schematic. And we see that it's 12 volts AC from ground to the hot side. But we know that that's just for one peak. And so we need to multiply this. So we'll say 25 volts on the secondary. We'll take 120 volts AC divided by 25 volts AC. That gives us 4.8 as our turns ratio. But we're stepping down, so we need to multiply this into 1. And that gives us a 0.208333 step down ratio. So go to the transformer, hit edit, or select edit. This is the turn ratio for the T1. Put in 0.208333. Hit apply. Select T2. Turns ratio 0.208333. Select apply. Select OK. There's our 2 turns ratio for the step down transformer. This execute. We know errors here. Select close window. And now you can see the pulsating DC at 12.6 volts instead of 120 volts. So our step down transformer is working fine. Okay, let's open up QUCS. Now we were going to build this exactly like the schematic and see how well it worked. But I did that and it didn't work at all. So I had to figure out why. And here's what I built. And as you'll look at the schematic itself, it's identical to the schematic. And we'll open up the schematic here. Hang on. This is my 30th video. It's amazing. Here's the schematic. Let's widen that out so you can see it. All right, and go down to the actual schematic. So as you can see, how the diodes are, the transformer is verbatim. I want you to look at this. The cathode of CR2 is feeding into the anode of CR1. That's the way they have it on the JAMECO dual adjustable power supply, and it works just fine in real life. But it will not work here. I'll execute a simulation. It'll go to 12%, and then it aborts. It's trying to make the net list, but it can't do it. So why is that? That would be the question to ask yourself. So I did it in 2 different ways. I first deleted the positive side. I mean the negative side, to see how I can get the positive side going. So I deleted the 337K. Excuse me. And I adjusted where the cathode of CR2 met with CR1. That's how we get in a full wave rectifier, that's how you get the positive pulsating DC voltage. So as I execute it, I've already executed it once, but we'll do it again. I'll show you that it does work. And it goes to 100%, no errors. As you can see right here, we have a 14.5 volts out. I got the probe measuring the output. We did 120 volts in, 60 hertz. The step was 201 points to T max. T max is 2 times the T period. And it works just fine. No problem. So I did that with the negative side as well. I deleted the positive side, opened it up, but this time I have the two diodes where they have a common anode. So the anodes are connected together. Same thing. I executed the simulation. It compiles completely. It puts out a negative 15.1 volts. I have a probe here, and I got the V out and the positive. The V out here, and then the negative on these two graphs right here. I have this set to maximum ohms on the rheostat for the positive and negative, and that's why we got the maximum out of the voltage for the positive DC and the negative 15.1 volts. So this put the full wave rectifier 4-diode schematic and see what happens. So I do that here. I execute the simulation. As you can see, the simulator has no problem with that. Takes a little longer though. I close that window. I have the same conditions, the equations for the controlling the simulation, and we could go over that. If you're interested, just email or text me or email me and I'll explain that. But here we have the positive side. We have the common common cathode right there for the positive. And then we have the common anode for the negative. We got 14.5 volts out on the positive side and a negative 15.1 volts out on the negative side. So this does work, but I had to rearrange the diodes. For some reason, even though it works in real life, it does not work in the simulator. The simulator cannot compile and create an atlas and then do the calculations. Okay, well, I hope you enjoyed that. That's it. Thanks.
NextPCB is a leading provider of reliable PCB fabrication and assembly services for engineers, startups, and businesses worldwide. Specializing in quick-turn prototypes to mass production, we offer multi-layer, HDI, flex, rigid flex, and metal core PCBs with strict quality control and superior customer care. Our advanced facilities ensure reliable performance for applications across consumer electronics, automotive, medical industries, and more. Embracing Industry 4.0 digitization, we streamline the entire electronics manufacturing process to give you competitive pricing and fast lead times, without compromising on quality. And our user-friendly online platform provides instant quotes, order tracking, and full transparency. In addition to PCB fabrication, NextPCB offers comprehensive PCB assembly services including global parts procurement, testing, certification, and box builds. Our 36 automated assembly lines include advanced inspection tools such as SPI, ALI, and X-ray, reflecting our commitment to quality and reliability. Choose NextPCB for exceptional electronics manufacturing solutions you can depend on.
You can see the NextPCB link by going to the More under this video. Click that, scroll down, and right here is check out our sponsor, NextPCB. Thank you.